In this course, we will cover the vehicle's fuel, rear axle, transmission, and exhaust systems. You will learn about their components, conditions, and service procedures. Upon completion of this course, participants will be able to identify the purpose, components, operation, and service procedures for the fuel system, rear axle system, transmission system, and exhaust system. The fuel system is designed to carry fuel from the fuel tank to the fuel injectors or carburetor. Current vehicles use fuel injection systems. The fuel injectors and carburetor control the amount of fuel that mixes with incoming air in an effort to maintain the ideal ratio, which is 14.7 parts air to 1 part fuel. If there are impurities in the fuel, they may clog the injectors. To avoid this, the fuel system also filters the fuel. Select the play button to view the fuel's movement through the system. When finished, select Next to continue. Each fuel system component plays a vital role in transporting fuel from the tank to the engine. Click each tab to learn more. When finished, select Next to continue. The fuel tank holds fuel. It has a fuel filler pipe and an outlet pipe. Mechanical pumps are attached to and driven by the engine. Electrical pumps can be located either in the tank or inline from the tank. They use an electric motor to pump the fuel. Pumps in most new vehicles are electrical. The fuel supply lines carry fuel from the fuel tank to the fuel injectors. The fuel filter removes dirt and debris from the fuel. It is located in the supply line before the injectors. The vapor separator separates the vapors in the tank from the fuel and routes them to the charcoal canister. After passing through the filter, fuel travels through the supply line to the injector rail, where it's distributed to the injectors. The injectors then spray the fuel into the intake manifold to be mixed with the air entering the cylinders. Any extra fuel not used by the injectors is routed through the return line back to the fuel tank in a return system. Note that some systems regulate the fuel supply by controlling the pump's on time. These systems do not require a return line. If the fuel system is damaged or poorly maintained, a vehicle may not start, it may develop a fuel leak, or it may cause damage to fuel system components. These conditions can be avoided by closely inspecting the fuel system. Select each button to learn more about fuel system conditions. When finished, select Next to continue. When dirt and debris get past the fuel filter, they can clog the fuel injectors, making the vehicle difficult to start. As a quick check during your inspection, start the vehicle to determine if it starts normally. If the vehicle cranks for a long time without starting, a potential cause may be clogged fuel injectors. Fuel leaks can be detected by the smell of gas or a stain. Fuel leaks are caused by damage or corrosion to seals, gaskets, or fuel lines. A damaged filler cap may also cause leaks. Caution: use care with fuel leaks to avoid fire hazards. A clogged fuel filter restricts fuel flow, adding more strain to the pump and contributing to premature fuel pump failure. It is also likely to cause engine performance concerns. Kinked or pinched fuel lines are other causes of restricted fuel flow. Most fuel system-related concerns are caused by clogged fuel filters. It's important to replace the fuel filter according to the factory maintenance schedule. In most vehicles, the fuel filter is located near the fuel pump and is accessible from under the car. A typical filter is comprised of the body, a filter element, an inlet, and an outlet fitting. O-rings or sealing washers ensure there is no leakage at the inlet and outlet. A retaining bracket holds the filter in place. Be sure to wear safety glasses and protective clothing when working with the vehicle fuel system. Only begin work when the vehicle's engine has cooled. Caution: make sure there are no sparks or open flames in the vicinity. Take a moment to review the tools needed for the removal and installation of a fuel filter. When finished, select Next to continue. Select each step to learn how to remove a fuel filter. When finished, select Next to continue. When possible, relieve the pressure in the fuel system at the Schrader valve on the fuel rail. Prior to disconnecting a fitting, place a rag over the fitting to deflect or absorb any spray from the pressurized fuel system. Thoroughly clean the inlet and outlet fittings. Place a drain tray beneath the filter to catch any fuel that drains from the filter when it is disconnected. Use the appropriate tool to remove the retaining clips with quick connection fittings. Always make sure to use the appropriate line or open-ended wrenches with threaded connection fittings. Place a rag over a fitting prior to disconnecting it to deflect or absorb any spray from the pressurized fuel system. Slowly twist and pull apart the filter to line connection and collect the fuel that drains from the open lines and filter. If necessary, cap the fuel lines until the new filter is ready for installation. Remove the retaining bracket and the fuel filter. Select each step to learn how to install a fuel filter. When finished, select Next to continue. First, determine the correct filter orientation. Any arrows should point toward the engine. Add a little fuel or petroleum jelly on both filter fittings. This helps the hoses to slide over them easily. Add the retaining clips, if equipped, so that the hoses do not slide off. If the vehicle uses clamps, they should be tightened at this time. Fully seat the inlet and outlet hoses on the filter. Reinstall any mounting brackets. Start the engine and check for leaks. Once the filter installation is complete, clean the work area and dispose of any waste material according to hazardous waste guidelines. In rear-wheel drive vehicles, the rear axle assembly connects the rear wheels, transmits rotating pinion motion to drive the wheels, supports the weight of the vehicle, and houses the differential. The differential allows the speed of the rear wheels to differ from each other as required by turning maneuvers and when the mini spare tire is in use. Differentials may be locking, limited slip, or conventional. The rear axle assembly uses a ring gear and drive pinion in a differential assembly to distribute torque evenly between the rear wheels. In addition, the rear axle gear set transfers torque from the drive shaft to the axle shafts. Note that the ring gear and drive pinion is often referred to as the ring and pinion. The rear axle housing supports the rear section of the vehicle and provides a surface for mounting the leaf springs and attaching the backing plates for the brake components. Rear axle fluid acts as a lubricant and a coolant. The fluid disperses heat generated from meshing gears while acting as a lubricant. Friction modifiers are used as an additive in limited slip units to prevent chattering. Select each button to view the rear axle assembly components. When finished, select Next to continue. The ring and pinion reduced driveline input RPM by approximately 2/3 and increased torque to the axle. If the vehicle is turning, the outer wheel has to cover more distance than the inner wheel. This means that the outer wheel has to turn faster than the inner wheel. The differential allows for this variation in speed between the two wheels. The rear axle shafts transmit power to the rear wheels. Select each button to learn more about where rear axle assembly malfunctions can occur. When finished, select Next to continue. Examine the pinion seal and both axle seals for signs of leaks. Check the differential cover for leaks, cracks, or dents. Check both axle tubes for any signs of physical damage like dents or creases. Also look for signs of leaks where the tubes are pressed into the differential housing. Ensure that the vent is free of any obstructions. Dirt and water can enter through the vent, which can result in damage to internal components. Replace fluid according to the factory maintenance schedule. If conditions warrant, it may be necessary to accelerate this schedule. When checking the fluid level, verify that the axle is level before removing the filler plug. The fluid should be even with the filler plug opening. Caution: if the vehicle's rear axle becomes submerged in water above the vent, fluid within the assembly must be replaced. Select each tab to view the steps to replace the rear axle fluid. When finished, select Next to continue. Place the drain pan under the differential. Remove all the bolts from the differential cover except for one or two of the bolts at the top of the cover. Loosen the top cover bolts. Gently pry the lower area of the cover away from the housing until fluid begins to drain. When all of the fluid has drained, remove the differential cover and clean the gasket material from both the housing and the cover. Remove any metal debris that is stuck to the magnet. Apply the appropriate sealant or gasket to the differential cover sealing surface. Reinstall the cover and torque all bolts to specification. Add new fluid through the filler plug opening until the excess flows from the opening. Note that an additive may be needed if it is a limited slip axle. Reinstall the filler plug. In front-wheel drive vehicles, the transmission and differential are combined, and the entire assembly is called the transaxle. The gear sets within the transaxle direct the engine's power into the differential. Combining the transmission and differential into one assembly reduces overall vehicle weight and requires less space. The transmission is the first component in the drivetrain. A vehicle's transmission transfers power from the engine to the drive wheels through a system of gears and clutches. Transmissions can be automatic or manual. In a vehicle with a manual transmission, the driver depresses the clutch pedal to disengage the engine from the transmission, changes gears, and then releases the clutch pedal to re-engage the gears. In a vehicle with an automatic transmission, the driver only has to select the forward or reverse gear position. Automatic transmissions use inputs such as accelerator pedal position and vehicle speed to select the appropriate gear. In a vehicle with an automatic transmission, 4 major components are used to deliver power from the engine to the wheels. Select each button to learn more. When finished, select Next to continue. The engine generates power and transfers it to the torque converter via the flex plate. The torque converter is a fluid coupling that uses fluid to create a power transfer path between the engine flex plate and the input shaft of the transmission. There is no physical connection between the engine and the transmission. The power transfer is done with just the fluid in the converter. The transmission contains multiple clutches, bands, and mechanical gear sets. These components work together to provide the necessary gear ratios. The gear ratios are changed automatically through hydraulic control of clutches and bands in the transmission. These changes are made according to vehicle speed, load, and driver input. The drive shaft transfers power from the output shaft of the transmission assembly and delivers it to the pinion gear in the rear axle differential assembly. The differential assembly transfers power to the wheels. Transmission fluid provides a connection between the engine and the transmission. It acts as a hydraulic fluid for the application and release of clutches and bands. It also functions as a coolant and a lubricant for the transmission components. The transmission filter removes debris that can result in damage to the transmission. This includes harmful impurities such as metal chips and shavings resulting from gear wear. Additionally, the filter removes material that results from clutch and band wear. All transmissions rely on fluid to function properly. If your customer has a concern regarding harsh or lagging shifts, the transmission fluid may be low. A low fluid level can cause the transmission to overheat. Transmission fluid will become contaminated over time. Debris from normal clutch and band wear will result in a darker fluid color. Contaminated fluid can clog the filter, resulting in poor transmission operation. Additionally, contaminated fluid can restrict the transmission cooler, resulting in an overheated transmission. Transmission fluid may need to be changed if it is dirty or added if its level is low. Perform the following checks if the transmission fluid level is low. Check for fluid leaks at all seals and gaskets. Also, check the case for cracks, corrosion, and pitting. Check for leaks from the transmission cooler inside the radiator and leaks in the transmission lines. To view the transmission filter replacement procedure, select each tab for more information. When finished, select Next to continue. Locate the transmission fluid pan under the vehicle. When removing the pan to drain fluid, remove all but 2 bolts. Loosen those 2 bolts slightly. If equipped, remove the drain plug to drain the fluid. Otherwise, carefully remove the fluid pan. Remove the transmission filter. Ensure that the old transmission filter seal is removed. Then install the new filter and seal. Ensure that all seals and gaskets are in place and that the filter is fully seated and secured. Clean and install the fluid pan and gasket. Refill and recheck the transmission fluid level according to the service information for the vehicle being serviced. Make sure to use the correct transmission fluid for the vehicle. The vehicle's exhaust system performs 3 important functions. It directs exhaust gases from the engine to the rear of the vehicle. It also ensures that the exhaust gases are treated to reduce emissions. Finally, the exhaust system reduces noise produced by the engine's combustion process. The exhaust system consists of the exhaust manifold, exhaust pipe, catalytic converter, muffler, exhaust hangers, resonator, and tailpipe. Select each component label to learn about its function. The exhaust manifold is attached to the cylinder head. It receives combustion gases as they exit the cylinder head's exhaust ports. The exhaust pipe, or pipes, direct exhaust gases to the remaining exhaust system components, such as the catalytic converter. Vehicles with inline engines have a single exhaust system. V engine applications start with two exhaust manifolds, requiring either a dual exhaust or a crossover pipe to combine the two exhaust pipes into one. Note that the crossover pipe is sometimes called a Y pipe. Catalytic converters are used to reduce harmful exhaust emissions. They act to burn off any remaining hydrocarbons in the exhaust stream. The muffler helps to reduce the sound that results from the combustion process. Exhaust hangers come in various sizes and configurations to accommodate different exhaust systems. They suspend the exhaust system beneath the vehicle. They ensure that a sufficient clearance is maintained to prevent heat from transferring from the exhaust system to the vehicle. Exhaust hangers typically incorporate rubber that acts as a vibration damper. The resonator reduces noise and can act to tune the exhaust to a specific sound or frequency. Exhaust gases exit the exhaust system at the tailpipe. An exhaust system leak can cause harmful gases to enter the passenger compartment. Leaks can also adversely affect emissions and cause objectionable noise. If the exhaust system is improperly mounted, it could come in contact with the underbody, resulting in a vibration felt inside the passenger compartment. Additionally, if the exhaust is not fitted properly to the underside of the car, it may drag and cause damage to the vehicle and the exhaust system. Several symptoms are related to exhaust system concerns. Select each button to learn more. When finished, select Next to continue. The smell of exhaust in the vehicle signifies a leak. Watch for leaks at the exhaust manifold, cylinder head connection, and other connection points. A ticking sound coming from the exhaust system should prompt a check of the manifold and surrounding areas for cracks or leaks. Check the exhaust system for signs of extensive rusting. A failed emissions test could indicate an exhaust system problem, such as an air leak before the catalytic converter, or a catalytic converter that is not working properly. The most common exhaust system service item is replacement of damaged or corroded pipe sections. Climate conditions can cause premature component deterioration. Select each tab for more information on the replacement process. When finished, select Next to continue. Disconnect any fasteners or flanges to isolate the affected section or sections. Once isolated, remove the section from its associated hangers. Note that if the exhaust components are severely corroded, heat or cutting tools may be required. Inspect the exhaust hangers for damage. Replace any components as needed. Note that if OEM components are not available, in some instances a universal hanger may be used. It should be mounted in the same location as the original hanger. Once the brackets and hangers have been properly installed, attach the replacement section. With the entire exhaust system suspended freely, begin fastening the new section to the remaining sections of the exhaust system. Use new gaskets where needed. Once the exhaust system is completely reassembled, verify that it does not come in contact with the vehicle. Be sure to check all connections for leaks by running the engine with the vehicle raised in the air.